Hello everyone, I'm Hima and I'm going to explain you about the change analysis with Evolizer and change distiller, which is written by Harold, Fleury and Martin. Discussing about the authors, Harold worked as a professor in the University of Zurich in the stream called Department of Informatics, as well as the Fleury was the former research associate in the University of Zurich Department of Informatics, whereas Martin worked as a assistant professor of software engineering in Delft University of Technology's Department of Software Technology. The paper mainly focuses to comprehend the need to make changes in the software system, and it also bring down to cost of maintenance. And the software system requires a maintenance, which means that a new code has to be added all the time. Because of this addition of new code, then the cost of maintenance is grows up, and this causes a burden in terms of maintaining the project. So this paper elaborates on how software maintenance and cost of maintenance can be kept at minimum. The main motivation is to understand the need to constantly evolve of computer software system. Here we should primarily understand why the software system requires this continuous maintenance, and this can also be viewed as why software needs to be evolved every time, and uh, and it is very crucial to understand here to describe the tools that can analyze and the changes made to the software system. Equalizer and change distiller are the tools that can be leveraged for the software maintenance, and this can also be carried out to the process of maintaining a large software, and it is very efficiently to uh, understand the changes made to the software systems. uh, and we should also be able to understand the analysis that was provided by the Evolizer and change distiller algorithms. This will be discussed in coming slides. Evolizer, a software evolution analysis platform. Here, Evolizer is an Eclipse-based application which is used to analyze the program evolution, and it has a features like version control system and bug tracking system. And Evolizer also allows you to import the code from the other code repositories or external code repositories. In Evolizer is an Eclipse which can be used for the software evolution analysis. Here comes the Evolizer's core architecture. This code design is mainly depends upon the Eclipse tool. This Evolizer platform has a persistency layer and data layer. In data layer, we have a versioning meta model, and in persistency layer, we have Evolizer Hibernate layer and Evolizer release history database. In these three uh, in these three models, the source code and all the data that has been changed is present here. And in the change distiller, we have a fine-grained change extraction and change history meta model. In this, the only analyzed part will be saved, and this will be run through the Eclipse. This Eclipse acts as a facilitator for these tools. Like Eclipse has a compare and Java development tools. This acts as a facilitator, and these tools are developed within the Java environment, and so they are highly these these are highly depending upon the Eclipse. The entire analysis is done by using the algorithms which is depending upon the Java runtime environment. Source code change extraction with change distiller. The change distiller works by leveraging the provided functionalities by Eclipse. Here, the change distiller will run on the top of the Eclipse environment, and the change distiller algorithm manipulates the ASTs of the Java source files. Here, ASTs means an abstract syntax trees where the code is actually stored. Uh, This Java code is stored in the form of trees while using this change distiller tool, and the algorithm that calculates an edit script that contains a basic tree edit operations where it transforms older abstract syntax trees to the current abstract syntax trees, like an older AST to the newer AST. And by extracting this source code, and this changes with Evolizer and distillers, this can be this process is very much straightforward and it is very simple. By analyzing the source code, there was a detailed study under which circumstances the comment and code was evolved and it was performed. And three studies were carried out to investigate the evolution of code and comments. So let's get started with the experiments. There are three experiments that are provided in this paper, and the experiment one is about to analyze how the proportional growth rate of the source code and comments has been changed throughout the time, and the experiment 2 is about to deal with whether the adding comments that is depends upon the source code entity, like uh, like it has been discovered whether the source code is marked significantly dependent on its type or not. And experiment 3 looks uh, like it will examine whether the comments are updated when the source code is changed, and these tools will create the data for all the three tests automatically and save it in the Evolizer for the future analysis. And the tools by using these tools we can access whether the comments to keep up to date or uh, least adapted, and this shows whether the integral to the development process. Change type of patterns. Here the source code changes that are mostly applied together. Mean for example, if there is a parameter, if we rename that parameter in the method body, and this will affect all the statements in the reference parameter. So these statements must be adapted to the parameter change. So a change type of vector also denotes the set of change type of method revision which is obtained from the Evolizer IHDB. Here are the few examples for change type patterns, and this is the initialized code, and the developers developed this code by using the parameter values for the particular scenarios, and then they inserted the parameter check. So this is shown by the Evolizer. So this is one example, and coming to the second example, this is the initialized code. Here there are two type of exit values. So the developer developed this code and they shifted multi exit value to single exit values. So they restructured it, and this is the another example for the change type patterns which is shown by the Evolizer. Coming to the conclusion part, software evolution analysis aims at retrospectively analyzing the software system's history to understand the software evolution and reduce the maintenance costs. This means that by analyzing the software evolution, we can identify the changes where it is happening and when it is happening. So if there are any common recurrence changes happening there, then we can detect that. If there are any common bug fixes also, or if there are changes happening very often, so then it will be easy to avoid that bugs, or we can find a way. And if these bugs are recurring changes, and the cost of maintenance could be reduced, and this would be a great help for the financial perspective. And here the tool presents the promising example how fine-grained source code change information can support evaluation. Here this tool works efficiently in identifying and recurring the changes like common bug fixes, and also they provide deep insights into how the software evolution takes place. and it is very crucial for any software management, as the changes help in very efficient management or maintenance the software. So it will if the software maintenance remains till date, it will be very long task for us to acquire the information in detail. So with the help of these tools we can ease the process, and we can ease the process of this software maintenance. And by understanding this how software evolves, we can better understand about this software maintenance too. So as per the author, the extending tools to provide the automatic support in order to prevent the bugs in future. And ending remarks is about the software maintenance, which costs can be considerably reduced. As a result, there are more resources that are saved while existing resources are enhanced. So this is the reference paper. Thank you.